So hello everyone, good morning, good afternoon, I can say. And yes, good early morning to Asia Pacific people. So I am Akriti Srivastava and I'm presenting on the topic of Azure Vulnerability Testbed, that is AzGOAT. So let's proceed further. Before we proceed with the slides, there's one thing which I want to tell, that the views and opinions expressed in this presentation are my own and they don't represent my organization's view. And who am I? As Alex has already introduced me, but still let me do the favor because I have written this in slide. I'm ECPPT certified security enthusiast and I have experience of 8 years. I have spoken at various multiple conferences, whether they were internal Adobe's conference or they were externals as well. Some of to name one is CS3 HTLM. That was for IoT, and I've been responsible for various disclosures. To name one is I hold Google Hall of Fame, and I've been a blogger, but have been a little bit dormant since some time. But yeah, I will start it again. So coming to the agenda, what we are going to discuss in this AzGOAT talk. So it's like we will be first talking about the threats that lead to compromise of Azure. And then we will be introducing AzGOAT, and we will be telling about the benefits. What are the benefits? We will be venturing in depth of AzGOAT, roadmap, and action items. So before I go ahead with further slides, I just want to tell that why the agenda is designed like this. So first portion will be telling that why we will be requiring AzGOAT. That's we will be elaborating on that, why there was need to develop such thing. And then we will be telling what is AzGOAT. And after that, we will be telling how it is going to benefit our audience, our security community, or I can say DevSecOps community. And then we will be seeing in depth of AzGOAT, we will be seeing demos. So we have 3 scenario demos. And apart from that, we have one introductory demo. And where we are and what is our roadmap for AzGOAT, that also we will be going through. Then yes, obviously we have action items. So starting with the very first point, that Azure is a market leader, and a proof we can see here in this chart. We can see that this is the worldwide market share, and Microsoft and Amazon are the biggest player here. And Microsoft holds about 18% of the worldwide market share. And another amazing thing which I found on net was that if you can see this statistics, this is again another proof that Azure is growing like anything. And again, it is a big competitor to big scale cloud service providers like AWS and Google Cloud, and many others as well. And you can see this is the current usage. I can just enlarge it a bit. So it's like current usage is 63% and plan is 6%, but this is experimenting is 20%. So this is a big proof that yes, Azure is gaining big boom in the market of cloud service provider. And yes, that comes with a new point, that it is coming in radar of adversaries. So yes, because it is getting more and more used, so obviously attackers will be trying to target more the more on the applications or services which are hosted here in Azure environment. So this is one thing. Then we will go through some recent breaches that again show that there have been an increase in frequency of attacks on Azure environment. So first of all, we'll pick up this icon. So any guess what it is? I know you all will be on mute. But yes, you can ping on chatbot. So this is Cosmos DB. So it was labeled as Chaos DB by Wiz. That's a research organization. So this vulnerability, which was found in Azure, was that they were able to get primary key as well as storage token of different customers. Almost they can say all of the customers, I can say. In some of the posts I have gone through, it was written that almost Fortune 500 companies were covered here. And this was done by a privilege escalation through their own Jupyter notebook. Through that, they were able to get such sensitive data, and from that, they were able to get into the Cosmos DB of another organizations. Then we have this one. Okay, this looks like something related to medical. Yes, you are correct. If you are thinking such, you are correct. This is Probase. So Probase is a UK-based firm, and it is for it's related to medical insurance and this thing. So the thing was that it attackers were able to get 587,000 records, and they were sensitive records. They were about medical checkups, have next one in the queue. Any guesses? This is windmill, I can say, solar winds. That has been pretty popular last year, very popular. And there were a lot of issues. Attackers, they were able to put malicious code in solar wind system. And through that, they were able to get into other companies as well. And they were able to pivot into Microsoft, and they gained internal code of Microsoft. So that was I think they got some code of Azure as well. And using that, they were able to gain AAD privileges, higher privileges, and storage token. Also, they were and not storage token. I think it was they were able to forge user tokens there. So you can see that there is a heavy increase in the frequency of attacks on Azure environment. So yes, it is need of the hour that we should become already we are proactive, but yes, if we want to learn more, if we are beginners, we should learn more about Azure security. Basically, I can say Azure environment security. So basically, it is a responsibility of client as well. Sometimes we say that cloud service provider, they host our data. It's their responsibility to keep track of our data, but no, it's responsibility of clients as well, that they need to protect their data. They should not put some misconfigurations or bad security practices to get it exploited. So what are the threats which we have seen which used to affect Azure environment? So let me take one example, Leak Secret. They have been pretty popular. Okay, I have seen a lot of them, and most popular is that infamous HTML source code. And this Git commit, this is like pretty popular. The developers push it into Git, and sometimes they put into Git commit. So that can be easily found. And if this code is public, then it's a very bad mess to clean up. Now, second one, guessable, reuse default password. Any guess what is this about? I think yes, you are able to guess it correct. So Paris, it's related to Paris Hilton's case. She put her default password as her pet's name. So this is one example of that. And then we have another. Okay, these are pretty simple passwords. But yes, one thing more, they should not be on sticky notes. That is really bad. Then another one we have is threat affecting Azure environment. We have web application vulnerabilities. Yes, they can be local file inclusion or code execution. They again bring up issues. And then yes, security misconfiguration, as we have seen in case of Probase. In case of Probase, the issue was that they have a public, their records were on a blob which had public access. That means anyone without authentication, they can access that blob. So that's a misconfiguration. So the solution we propose for this is AzGOAT. And AzGOAT, when we talk about that, AzGOAT means that it is a playground. It is a playground where you can practice, play, and you can learn more about Azure vulnerabilities. So we have recently seen that there are many good playgrounds for web and AWS. To name some, we have OWASP Juice Shop, and we have WebGoat. So they are very good. And to admit it honestly, that yes, I have also learned a lot from them. So while I started researching about Azure security, I saw that there is no such, I don't know, in my knowledge, there was no such playground, and literature about the chaining of attacks that in Azure environment, that is also pretty limited. So came up with idea that let's have one playground where we can put up some chaining of attacks, which can help other people who were beginners, so they can understand more that how these attacks can work and how they can be leveraged into uh, total compromise. So how it's going to benefit you? So for now, we are targeting three communities, that is developer, security, and operations. So for developers, it will be for them to understand how insecure coding practices, which are very common, how they can help them, how they can cause total compromise of the Azure environment. So they need to understand what all uh, bad coding practices are there which can mess up the whole environment. And for security persons, it is a boon. They can learn more about the lateral movements, how attackers perform lateral movement in case of Azure environment. uh, you have to exploit a web application or any function, and how you can move into the whole Azure environment, that we can know from here, and for enhancement of security knowledge related to Azure. Then coming to operations. So for operations, I'll just, so for coming to operations, we have, we have seen an example of misconfiguration there in vlog. Yes, so this is for operation people to understand how bad configuration practices, misconfiguration, I can say it got a raise. I should say it got a raise in OWASP top 10 2021. It moved to A5. So it's very common, and yes, we need to learn that how to avoid that in Azure environment. So that will we can learn from is the AzGOAT for operations. Then venturing in the depth of AzGOAT, so we will be going through the network diagram. Then we will be having an introductory video for it. I should have demo, not a video. Then we have scenarios, walkthrough, and demo. So when we come to network diagram of AzGOAT, so this is what we have implemented for, this is what we have implemented for now. Let me just enlarge it. Just a second. So if you can see here, these are the few components which we have implemented here. So user, this will be person who will be using AzGOAT. So they will what they will see in this environment is that a public address is assigned, which is a static address for this particular VM. We have two Linux VMs which are deployed here, and one is associated with managed identity. And using that, they can query storage account and they can query SQL database. And we have a function app, and using that function app, they can perform some functions, like they can print out some details that is here. And this particular VM is internal in nature, it can't be accessed from outside. And this is also fetching data from this storage account, and this may be storing some important data files. Then we have subscriptions. So for subscriptions, I will be using my personal account. Apart from that, I also have put this here because I will be researching further on subscription exploit. I mean, some scenarios which are related to chaining attacks related to subscription or key vaults and queue storages. So these things, three things are under progress. So that is one thing. Let me move to blob storage. Yes, I forgot to tell about blob storages. There are two blob storages. One is public in nature, one is private. Moving to the introductory demo. So first we will be going through the walkthrough of AzGOAT resources. From network diagram, it may not be much clear what I was talking about. So this is my account. If you can see here, AzGOAT is deployed here, and this is the resource group where I have grouped all of my resources. So if you can see here, all SQL Server, virtual network, VM, these all are listed here. So this is corporate VM, this is internal in nature. There is no public IP, though it is written here, there is no public IP. and security groups attached here all are present. This is our function app which we will be testing. This is that machine which is open to public, and then we have this security groups associated with it, and this is associated with our function, this particular account. So these things we have for now. Let's just open something and show you more about SSRF machine. So SSRF machine is having this DNS name associated with it, and this has a public IP assigned to it. And if we see the networking, so for network security group, we have allowed certain ports, but we need to allow this as well for Flask application to run. So it has a Flask application running, which will help us to run the application. So this was the walkthrough of AzGOAT resources. Now setup script. If we have to make all these resources in Azure, it will be a very hectic task. So I am working on these automation scripts. So if you see, this is a copy of the main script which I'm working on. So we were able to successfully create resource group, virtual network, subnets, VMs. Two VMs we were able to create, one private storage account and one public storage account. We were able to create, and yes, along with their container and plog file. So they have their data also uploaded there. We have NSG set here. So almost this script is like 80% complete. There are some small changes which I need to make, and plus I need to incorporate SQL servers automation here. That is one small task, and another is that I need to form a cloud init script for deploying the application, vulnerable application in the VM. So just for your demo, I'll show a small snippet because running this whole script will definitely take a lot of time. So I have copied this main.tf here, and it will be just creating 16 resources, that is 2 VMs and one storage account with its subnet and resource group, and with a public IP, it will be creating that. So let's run this particular script. I'll open my Terraform. Okay, so we need to open the PowerShell for this, and yes, I have already logged into AZ. I've already performed AZ login here, so I've already have access to this account, and I have installed Terraform 1.8.0 here, and I've already performed an init command on it. So if you need more details how we can do it, you can find it from Microsoft blogs. But just to create it now, let's see the plan. So plan is kind of debugging, compiling, you can say. I mean, very basic term. It's not compiling, but it's very similar that it will check whether these resources can be formed. Is there any syntax error or something? It will point it out. So it will take some time. It will show, okay, these 16 resources will be formed, and this is the list which all are getting formed here. So it has started the plan. So if you can see, these all resources are getting created here, and which location they are getting created, what's their name, everything is provided here. So we need to run this script. Okay, I need to move it on. Now we need to create the resources. For that, we will simply run apply. So it will start the creation of resources. It will again take another 2 minutes. So just to save your time, we will see how it's working at the backend. Just a second, how to hide it. Just a second. So for this purpose, I have created another account. So this is my automation account where it will be creating all these resources. Let's see if it has populated any resource here. So I'm having two accounts here for AzGOAT. One is for automation and one is for creation of where AzGOAT is deployed. Okay, I forgot to do that. So let's see what's happening here. We will keep on refreshing. Maybe it will get AzGOAT created here. So if we see on backend, it is showing that it is able to create a resource group with this name, and these are some resources which it is trying to create. Okay, let's wait for some time. So we are able to get virtual network as well, subnets, network security groups, association, everything is done. We got storage account, creation complete after okay, and it's creating blops. Okay, now it is trying to create virtual machines. So this is a very small snippet where we will be just seeing two VMs and these resources with subnets and NSGs formed. Okay, should stop at any time. So I think another couple of, another 20 seconds it should take. It should end after that. So we can see 16 resources are added here. Let's see, we can, so you can see AzGOAT resource group is completed, and what more we can see. Okay, so these are resources formed. We are able to create two VMs which have proper managed disk assigned to them, and this is the storage account which is created. And if we see the storage account, it has created the containers as well, and related file also, block file also it has uploaded here. So, and for VM also, if we open one, we can see this is running, this has public address assigned to it. So everything is done through this automation script. So this is the walkthrough of automation script which I wanted to show you. And there are some few things we need to add up there uh, that I'll show in roadmap. So this was an introductory demo for the setup script. Now we'll be going through the AzGOAT scenarios. So we have three scenarios here. No metadata leaks, is it? And another is publicly exposed storage to a compromised database. And then we have cloud malfunction to range shell. Taking up the first scenario, no metadata leaks, is it? So the first part, the first thought which will come to your mind is that Azure is not affected by metadata leakage by SSRF, because they have a good policy of header that every time whenever you will be querying metadata services, there should be a header of metadata true. Then only you will get a proper response. But in this case, still we were able to get the metadata. So it's not the fault of Azure, it was fault of insecure coding practice, because of which there was heavy leak. So yes, to cover up my point, there is strict header requirement in metadata API. And taking a proof, I can show you a pic of Jira. This was a research done on Jira. Jira was hosted on all of these environments. And if you can see, metadata leakage from host is 0 for Azure. So let's take the scenario one. again. So let's take a story. So Anna is working for a very prestigious firm, and she has developed an extension which will be integrating some external connectors. And she has developed some such kind of extension there, and she gets a call from a friendly attacker. I can say friendly adversary, and that's a little funny term, but yes, she gets call from friendly adversary, and he or she tells that this there's a there's a lot of data is getting leaked, and metadata is getting leaked, and yes, the person was able to perform a lateral movement, and they were able to get access of their storage account of this organization, which had some important data. So let's investigate this case. So first, when we investigate this case, I will be also showing the demo. It was found that it is vulnerable to SSRF, and metadata header was enabled in code. Now, when we open this code, we can see. So this is our main file. If I open this code in AzGOAT, let's see scenario 1, and we have this code in Hello World. Let's see what's here. So if you see this code in header, this is there. So what it was done, that the person, it was investigated out that, okay, this external extension was, this connection was required. And also because of that, she has left one debugging information here, where she wanted to check how, if they are able to query the storage account through their managed identity accounts or not. So for that debugging, this was left there. So this is, so every time request will be made to that particular URL, this will get passed in the headers. So this was a one debugging code which was left intact in that production code. And when we see this, so this is that URL uh, where this code was hosted. And if you can see this, if you enter any integration URL, just we can put google.com. It's, if you can see, this is a proper SSRF here. Now, if we go back and try to fetch metadata details, let's do that. So let's see if we can find out compute ID and other stuffs related to, or subscription ID related to this. I'll also show what I have passed. So this is present in Microsoft Documents as well, where we can find uh, data related to subscription ID or other related things. So when we perform submit, so from here we were able to get subscription ID. Now let's move back, and what more we can discover. Let's see another thing. We have, let's see if we can get managed identity token. So this is for querying the REST APIs of Microsoft, which is related to managed identity. We can get token here, access token. Now how we are going to use it? So for this, we have one script here. So this script is inspired by Carl Forsin's blog. If you see this script is taking a particular token. So this was my earlier generated token, and this is this subscription ID. I'll just put this token once again for your view. I'll modify this script. Okay, so I think we have script ready. What this script is doing, it will be fetching the list of account, storage account, and it will be fetching keys related to that storage account. So let's run the script and see what goes. So if you see, it has this internal storage account, which was private in nature, and we can get the key. So let's check in Storage Explorer if we can go further. Let's try to connect to Azure account. Okay. Next. So it has successfully added this connection here. Let's move to blob containers, see if we can access this file. Yes, there is some important data. And when we try to open it, okay, it's taking some time to open this data. Oh. So yes, we were able to replicate the scenario one, how attacker has performed this lateral movement. So this was one scenario. Now moving on to the next demo. So that's scenario two. So we have this thing like, as I've earlier discussed, that we have publicly exposed storage is sometimes present, but how it can compromise a database. So let's take an example of another story here. We have Yummy Foods, and Yummy Food is online food delivery company, and they have developed some app. They have put up some code on their blob storage, and they want pen testers to review that code. Also, one of their focus point is that they have deployed Azure SQL DB there, which is very restricted. They can't that DB can't be accessed from remotely through internet. So the challenge is to access Azure SQL Server remotely. So this, because in Azure we have this thing is restricted, IP restricted. Only internal machines can access it. So when we investigated it, so these were the things which attacker did for lateral movement. They were able to, source code was revealing a blob storage URL, which was another blob storage URL, and that was publicly accessible. It had some VM credentials, which was in that network, which had access to that SQL database. And in entering into that VM, they were able to get web.config file, and through that they were able to get connection strings of that SQL server, and they used a script to connect to that SQL server and fetch customer record from there. So let's see its demo. I'll again jump back to another browser. So this was the code which they have hosted in a blob file, and if you can see here, we don't find any connection string here, but this code is somewhat uploading or downloading some data to blob storage, and blob storage URL is given here. This is the blob storage URL, and if we try to access it, you can see that it shows the machine's detail. Now when we try to connect to it, so this is a public IP, let's use it. Go further. So we are able to log in into it. Let's see if we can get root access. Okay. So it shows that tester is not a sudo file, and this incident will be reported. Okay, let's see what more we can do. Let's go to their directory, www directory. Let's see what all they have. So they have these many apps which are hosted here. Let's go to Yummy Food, and we can see web.config here. So when we open this web.config, we scroll down, we can see a connection string is getting revealed here. So what we are going to do now, we are going to use a script. Again, it's inspired by Carl Fossen's blog, and I'll just show. I've already copied the script here in its home directory just to save time. We'll just open this script, and you can see the same. This is the database name, sorry, database server. So this is provided here. We have populated all the values here. username and password, which we found here. And we are trying to fetch one table from it, which is customers. We just want to see if it is able to fetch details of customers. So let's run this script. And when we run this script, we can see, okay, these are the details of the customers which were stored in that particular database. And even though it was restricted in nature, but then also how attackers were able to perform a lateral movement and get these details out from it. So this is one step. And now coming to scenario 3, we have cloud malfunction to range shell. This you must have experienced most of the time in case of functions. So we have a function here, and which is we are having a function here which on exploitation is doing leakage of storage token, and we are able to perform, I can say we are able to get reverse shell. For this demo, I'll be showing the restricted reverse shell. So I'll just open my function. If you see this function, this is the URL, and we have to pass on this parameter q is equal to something. So if I provide some improper value, then it shows that this particular thing is not found. But if I try to provide ifconfig, this is very restricted. This doesn't show much. It will show that it will show that this is not enabled. ifconfig is not enabled. Let's see what happens here. So it shows ifconfig is not found. Okay. So let's put here env. So there's a lot of data here. You can see a lot of data. So you can see that storage account name and its key, related key. You can see a lot of thing here. So basic thing is this is a meet here. So you can again try entering this data into Storage Explorer and you can get the detail. But apart from that, there are a lot of things about this particular host which is hosting this function. It is getting revealed. What backend they're using, everything is getting revealed here. So this is one thing. And I'll just take another example of reverse shell. I'll just be fast. So for this particular thing, I need to open up my the VM which I have started here. Let me connect to this VM. Though I don't have much time left, let me make sure I do it fast. So this was from my automation account. This is another VM which I created. Just a second, maybe some error here. We can do one thing, we can try to SSH. Okay, let's open putty again. Okay, so we have password. This password here. And yes, we have access to it. Let's start a shell on 443 because this particular port is enabled. Okay, so we have started a shell. Now let's move back to our slide. Here we have copied this particular code. Let's change the IP also. So we are trying to get a reverse shell here. This is a Python one-liner code which we have used here to get a reverse shell. So I have already put the port as 443. Just we need to change the IP. Let's see what happens here. Oh, thing is happening. Okay, all right. Let's move back to PuTTY and see if it gets something. So it will get a restricted shell here. That is one thing. Let's wait for some more time. I hope IP I have provided is proper. So this was okay. All right. So let's pray to demo God. Oh, demo God, make this demo work. All right. This is stuck, but however, we used to get it earlier. In the meantime, I'll just move on to the next slide just to cover up this time. So this is the roadmap which we were planning for. So which we have planned for. The phase one is the planning and creation of scenarios. And phase two is the automation of whole setup which we are performing right now, and we want to make it open source so that whole security community and everyone can use it. So also we are planning to integrate some privilege escalation scenarios which are related to subscriptions or managed identities and key vault access related scenarios. Plus we are working on Azure queue scenarios. We want to research more on the Azure APIs. And phase four, we want to regularly update with the AzGOAT with the new scenarios, and we want to maintain, we will be maintaining and fixing the issues which are reported for AzGOAT. So we will be working on that. So before parting note, just let's have a look. Okay, somehow this is not getting us here. Maybe I gave the wrong, okay. So for parting notes, I'll take up the moral of the story is that eliminate the root cause if it is in your control. So the thing is that we know that in the three scenarios, we know the root cause. So one was debugging code was enabled. And even though we remove the debugging code, still it is vulnerable to SSRF. I mean, we need to fix the SSRF as well. So that is the root cause. Then another thing is when we talk about Azure security, Azure environment security, I should say. So there's a strong need for Azure environment related testbed where we can learn, practice, and we can learn a lot there. So web and AWS, as I've already told, they have dedicated testbeds developed. And yes, there should be more encouragement on Azure environment, I should say, not just Azure security. It should be Azure environment related security as well. So there should be something more related to that. And when we talk about action items, so yes, there is call for collaboration. If some of you want to, if any of one of you want to collaborate in this AzGOAT, please do let me know. We can make it more exciting, and yes, there can be very good scenarios here from which people can learn a lot. And yes, we can develop more scripts which can help them to uh, perform pen tests better. So any questions or feedback, do reach out to me on this email address. And for the last time, let's see, there is one timeout error here. All right. So maybe there is something wrong with this reverse shell script.
A comment said that there was a wrong IP in the reverse shell command. Maybe you can.
Oh, okay. I have
double
changed
two at
it.
the beginning of the address. Maybe
All
not.
right. Maybe, but this was, I think this is correct one, right? 20, this one I have started. I have changed it here while I was copying. But yes, it was working. I'm not sure. Maybe 4 there's something related to Okay, all right, I got it. It's because of NSG. That NSG is not enabled for 443. That's why it's not working. If I enable that port, it will start working. If I add that inbound port, that will start working. Because 443 inbound connection for 443 is not enabled. That's why it didn't work. I think it should work now. Oh God. All right, it should work now. That's what's, I think, because of NSGs, this thing wasn't working. Yes, we have this restricted shell now. So if you can see, we can ls, and I mean, we can see which directory we are in. A lot of things are here. We can move out of this and we can see what more things are present here. So this was that scenario 3 demo, which was pending from my end. That got successfully completed. So thanks DemoGod for that. And this is a reference which I have provided here, from where, I mean, a lot of ideas we have, a lot of research we have done for making this testbed. And at the end, I want to thanks OWASP for giving me such a great opportunity to present in front of such a wonderful audience. Thanks a lot.